So we're going to get into the next stuff. Any lingering last minute questions about old stuff before we get into new stuff? This is the new stuff. All right. So what we're about to get into is a different way for somebody to give me a list of data. That doesn't sound ground shaking, but we will learn different distributions of data. And every time we have a different distribution to work with, what are the two most important numbers to summarize a set of data? I want to be able to calculate those every time. What are those? What are the two most important numbers that gives you an idea of what the data is?
The mean and the standard deviation?
Yes, where the middle is, and we've chosen the mean to be the generally best measure of the center. You with me? And then how spread out it is. So if I know where the middle is, and then know how spread out it is on average from that, I have a decent feel for the whole data set without looking at all the freaking numbers. So if I have a data set of 58,000 numbers, I'd much rather somebody just tell me the mean and standard deviation is instead of look at all 58,000 numbers. So those two numbers are a beautiful summary. And if I know those two numbers, I can create z-scores. Oh shit. Some of you guys didn't have the z-score formula on your formula sheet. I didn't understand that. So we had it up on the board, right? What is the z-score formula? I like it. Yeah, x minus the middle divided by the spread. So x minus the middle divided by the spread. And my claim is that formula never changes. And some of you guys might say, there's two of them, Jeff. No, there's one. There's always only one. The point we're interested in, minus the middle divided by the spread. The formula never changes. How are we doing? We all right?
I could not recognize that symbol.
Which one?
Like the little
fat I remember that.
On the test, I was like, what
You
is
came up
this?
and asked me, and I told you it's the fat R, so it's always good. Yeah, so the font on the computer makes it kind of like pretty fat. And sometimes when I write it, I'm like in a fresh, so I make it skinny, so yeah, okay. It's like Southern accent versus Bronx accent, right? Same symbol, same word, just looks and sounds different. Okay, so we're going to hit a new type of way to have data given to us. And so we're going to develop a quicker way to figure out the mean and the standard deviation because those are the two most important freaking numbers. So if there's a quicker way to get those, if it's given to me a certain way, yes, please, right? I want to do it the quicker way, right? All right, so, all right. You guys have got to come with me on this. I'm going to make a very small set of data. We're going to analyze it a couple different ways to understand why the math works. Some of what we're about to do, you're never going to do again directly because it just is showing you why stuff works. And then we'll do an example fully the straight way without any extra shit. And then, of course, remarkably, I've got a handout. It's amazing. Okay, all right, maybe. So we are going to, our goal is to be able to figure out the mean if it's given to me like this. And then what do I got to be careful? 7, 8. Oh, okay, good. That works. Yay, 22, 73. Hi. Okay, that works. Can you guys see what do you think that symbol there means? Two different ways you can look at this, and they both are accurate. Probability of X or percentage of X. So if I ask people, how many, I don't know, how many TVs do you have? 27% had 3 TVs, 51% had 4 TVs. You guys with me? Or what's the probability then that I pick somebody out of the sample that had 4 TVs? 51% chance because 51% of them had freaking 4 TVs. You guys with me? So what's it look like? Percentages and probabilities are definitely related. And in a lot of problems, you can look at them as both ways. Okay. I like it. So, to build up to this, we will do this example in a minute. Let me do a much simpler example to show you why the math works, and then we'll attack this with the new kind of organized math we're going to create. I love you guys. Stay with me. Some guys are like, I'm already out. All right, so I'm just going to give us 10 data points. Hopefully 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yay, Jeff. Okay. Every time I do this kind of thing, I get people that are like, why the shit are you doing it this other way when it works fine? This is a very small set of data, right? Right. So this is an example of I'm trying to bridge what we know and show why it makes sense of a new way to do things. How do you find the mean? How would you just tell me how you find the mean of these? Add them all up. So can I do this? Is this okay? I got 2 1s. You guys with me? Plus 3 2s, plus 4 3s, plus 1 4. Right? Divided by 10. Okay. No idea if I can see all this. Let's take you back here. Boop. Good. This is exciting. Do. Okay. Now, okay. So the old way, not the old way, but the different way. But I would just do 2 plus 6 is 8, plus 12 is 20, equals 4. So 24 divided by 10, I get 2.4. Is that cool? Right? And this is where people would start to block. I'm going to go over here and do stuff a different way. It's going to take a little longer because I wouldn't normally do all this shit. I'm just trying to show you why this matches with what we're going to do. And you're like, you said that 3 times? And I'm like, that's about how many times I got to say it before everybody hears me. So another way I could do the same math is 2/10 times 1, right? Is everybody cool with that? Math don't give a shit. Isn't this 2/10 times 1 plus 3/10 times 2, right? Plus 4/10 times 3 plus 1/10 times 4. Don't tune out. Don't tune out. We're never going to do exactly this shit, ever. I'm going to connect this to this. Isn't this, and again, this is unnecessary, but oh well. Isn't this 0.2 times 1? What percentage of my data was 2s? 30%. 30% were 2s, right? 20% 1s, plus 30% 2s, plus 40% 3s, plus 10% 4s. And of course, if you do this, what do you get? You 0.2 plus 0.6 plus 1.2 plus 0.4. So you get 0.8, 2.4, the same stupid answer. Of course, math is like, all right, human, you can organize this however you want to. Okay, now. You guys, I love it. I can just tell on your face, right? All right, it's a bunch of numbers did shit. Yay. Is everybody semi with me on this? I mean, both ways work. What I've given you, which way would you rather do? Well, this way, because look, I was done, right? Now, if I give this to you, can anybody tell me what that list would look like for this? If I started writing 3s down, how many 3s would I write down? What is 0.27? As a fraction. 27 out of 100. So I have 27 3s, 51 4s. So I could say, if you want to do it that way, go ahead, but then I'd look at you like, you sure about that? Is everybody with me? I really want you to be with me. This was easy as shit. Why did I do all this shit? Just to show you that what can I do instead of making a stupid long ass list, what can I do? Well, what did we do here? We took the percentages times the value, right? 27% of my average is going to be made up of 3s. So this would be x times p of x. So that's 3 times 0.27. What is that? Oh, what is it, Jeff? Anybody help me? Oh, okay. And then 4 times 0.51. Right? 5 times 0.12. Do you guys see what I was trying to do, my insanity? This here is this step here. Yes?
So are you going to add those numbers?
Yes, and that will be the
mean?
that will be the mean. So when I write it, as if I had the list, 27 threes and 51 fours, I'd add them up and divide by 100, right? Do you see how each of these already has a divided by 100 in them? That's why I don't have to divide by anything for this. It's already built in. It's like ragu, it's in there. It's a very old reference. I'm a very old man, so oh well, too bad. Okay. This is going to be 0.6, right? Yes. And then 6 times 0.10 is also 0.6. So the mean, the formula for the mean, when I'm given x and p of x, the formula for the mean is the sum of x, p of x. I add up the data values times the weights. What's the heaviest weighted data value? 4. 51% of the data was 4, right? So the average should be around 4, I would guess. Let's see. What do I get when I do this? 3.85, 3.05, 2.05, 4.05. Anybody help me? 4.05? That's it. Okay. Thank you. So if I did, right, 27 threes, 51 fours, 12 fives, 10 sixes, add them all up, divide by 100, I would eventually get there. Do you see how now that way is quicker? If they give it to me like this, I've discovered a quicker freaking way to get the mean. What's the average of 3, 4, 5, 6? Just those 4 numbers. What's the average? You can do it. What's the average of 3, 4, 5, 6? It's going to be in between. Huh? 4.5, right? Why was this less than that? Why is this 4.05? Because the heaviest weighted data point is 4. It's going to pull the average towards it, right? If I would have made this one 51 instead, and this one 27, it would have been even closer to 3. It would have pulled it. Gravitational pull. That's awesome. Or not. You don't have to look at it that way. I hate spaceship. All right, then just look at it mathematically. I like to think of it as gravitational pull. It's really cool. Okay, maybe.
So the formula we're going to be using is...
So for the mean, we got our first official formula. Here's the next really cool thing I want to point out. If the average age of Grossmont students, I know I keep coming back to I don't care. The average age of Grossmont students is 26, and you have a classroom over there. What's your best guess? What's the expected average age of the people in the classroom over there? 26. So doesn't it make sense? Another name for the mean is expected value. Doesn't mean we expect it to always happen. It's just that it's the best guess. It's the thing I expect to happen the most. You guys kind of with me? So when you see that phrase, expected value, they are talking about the mean. And look at the first 3 letters of the mean formula. This kid's so much ass. What's the first 3 letters, sort of? E, X, P, expected value. Now that's not really, David Blaine shit, but it still is kind of cool. Maybe. So 2 things here. Did anybody notice I had to be kind of careful when I was making this?
Yeah.
When did I stop and think? There. Why? Because I have to have the probability always has to come out to be
1 and 1.
or close to 1. Right. We did relative frequency before where it came out to be 99.9%, right? Because we rounded. So here I just gave nice whole number kind of stuff, percentages, right? So it came out to be exactly 1. What else must be true about all these? This is kind of almost too basic to think about. Any probability by itself has to be between
0 and 1.
So if I ask you, if I give you this kind of problem, and I say verify this is valid, what do you got to show me? That these add up to close to 1, or exactly 1, and that each one is between 0 and 1. Yes, there you go. So don't miss that question. There are 2 parts to that question. Don't give me 1. There's 2 parts. I like it. Probably I'm saying it like that because that's a mistake people always make. So don't be like that.
Sorry,
Yes.
you said that it was, they have to be equal or close to 1,
Yes.
and then they have to be.
Each one has to be between 0 and 1.
No.
So you would say that like
You can't have like a 1.
the sum of p of x in this case is 1, and each p of x 0 less than or equal to p of x less than or equal to 1.
So it wouldn't make sense to have 1 that's already 1. 'Cause then it would,
And then everything else is 0 then.
yeah.
It's kind of silly, but oh well. It
Okay.
could happen, right?
Right.
And why do I need both of these? Now this is also very silly, but couldn't I have like this? Do these add up to be 1? Do these add up to be 1? Of course they do, but is this valid? Oh hell no, that's why you got 2 things you gotta tell me. One thing by itself ain't good enough. And don't say, well you can see it. No, it's all about you telling me so I know you know what to look for. I like it. Maybe. You guys look really concerned. We haven't done too much yet. Alright. Now of course, so that's the mean. This little formula we got is going to be on our next iteration of our formula sheets. Right? Is that little dude there? Now we've got to figure out what about standard deviation. Right? Yes, Jim? Okay. So, I want to point something else too. Before I get into standard deviation. What was the original formula for the mean? And now what's this new formula for x, p of x stuff? What looks like it's missing? I said this earlier, but I really want to make a point out of this. Huh? The n, the divided by n. But what's on the bottom of a probability always? What's always the bottom? The top is the number of the match what I'm looking for, divided by the total number, n. That's what I meant by it's built in. Those formulas are the same. They've just been reorganized to make more sense in a different situation. Maybe. Formulas actually never really change. They get tweaked a little bit, they get reorganized. Okay. All right, now. A little warning in advance. I'm going to show you where this formula comes from. I think I'm going to do it all on the side here. That might make more sense. So the standard deviation formula, let's do the variance formula from before. All right, this is for a population. So I'm assuming this is a population. You'll see why. Well, I'll tell you why right now. The bottom of p of x was n, right? We got a sample. What am I supposed to divide by to get the standard deviation? In this case, I'm going to be multiplied by p of x, which has an n on the bottom. So therefore, that becomes sigma. So I always assume I have a population that I'm working with. Okay, maybe. So what should make sense is if I should have erased this, but if this used to be this and that became this, basically the division by n became this because p of x has divided by n in it. This formula should then become this, and it does. Again, they're the same formula, aren't they? You guys You guys see that? They are the same. Okay. Always hope. Really hope. So in this case, let me see. I don't know if I need to explain this anymore, but if I did x minus the mean, what percentage of that would be coming from 3? This is a little bit weird, but if I did, don't write this down. If I did x minus the mean, that would be 3 minus 4.05, right? But how many of these do I actually have? 27% of these is what I have. So if I take every one of these that I get multiplied by its weight, it's like I'm adding every time there was a 3. I'm adding that in. I'm adding that in. Maybe. Now, if I go, now here's the next little bit of algebra. I'm not going to go all the way through this because you could have an entire semester of summation algebra. You don't want me to make this into a summation algebra class, right? That sounds a little gross. I love it. It's awesome. You don't want me to do that. But I do want to do a couple of the first steps here so you can buy into what this becomes. I call this the conceptual formula. Because what does standard deviation always mean? Oh shit. What does standard deviation tell you? Yes, be a little more specific. I'll start us off. The average distance from the mean to all the data points. Let me say that again, because it might show up on a test at some point. The average distance from the mean to all the data points. That's what standard deviation is. And that should make almost too much sense. And of course, that's what kind of drove us to creating the formula for it. We didn't have the formula and then we figured out what it was. We figured out what we wanted and we made the freaking formula do it for us. Okay, maybe. Average distance from the mean to all the data points. So obviously, if all the data points are the same, it should be 0, and it is. If you calculate it, it'll be 0. Right? 5, 5, 5, 5, 5, 5. What's standard deviation? 0, because they don't get away from the mean at all. Those kids never left home. Or moms go crazy. All right. So again, anytime you see something that is a standard deviation or is related to a standard deviation, you have to see this shit in it. Why does this shit make sense to see in there? Because it's the distance from the data point to the mean. That will be a piece of every standard deviation formula ever, because that's the basic idea of it. So what I'm going to do is, while this is really good conceptual shit, it would take a lot of work. It'd be so many freaking columns. Do you guys see that? I have to make so many columns just to get to that. I'm going to make this so I only have to do one more column. That's what I'm going to do. Or you're going to help me. So guys, look at this. Just tell me. Put your algebra brains in. Right? In case you have it separate. I don't know. It's like a moto thing. If you saw that in algebra class, besides the mu, now we know what that is. What would you want to do with that? You can't square root. What would you do with something that looks like this? Starts with an F, yeah. FOIL, yeah. And I'm not going to get into the whole thing. I wish they never came up with FOIL because it's bullshit. We don't need it. It's just repeated distribution. That's all I got to know. But I'm going to let go of that for not really. So can you guys just take this piece and work with it? Do it. Multiply it out. You should not end up with 2 terms. If you do, you did something wrong. You should follow the advice if somebody said write it twice. If you're not sure what to do, at least like draw it up or something. Make it look like you're trying. Or really try it. That's a better thing. I'm not going to look at it. Oh, okay. So what does something squared mean? What's 7 squared? Why? Because it's 7 times 7. So you have this thing twice. I have this thing twice. This thing twice. You're thinking of like difference of squares shit. That's not what this is. This is an exponent, so I write that same thing twice. You can't, it's easier if it wasn't, but oh well, it is. Right. What are you guys getting? That's what you should get. Now, compared to full algebra class, we've done remarkably little algebra in this class, but I mean, you should be able to do that. So, now watch. I'm going to bring back in. So I just pulled this piece out. Let me bring back in this shit here. Is that cool? Just brought back in the other symbols. So we just took this and blew it up. Let me put that back where it was. Now here's the part where I'm not going to do every step. If you're curious, you can come to my office. I can show you all the steps. There's not too many other steps, but they get a little freaky. But can you see that the first, what would I do with this guy? Distribute, right? I love some of you guys are like, oh my God, this asshole and his math. All right. I get this, don't I? The first term I get is this. Is that cool? Is that cool? Minus a lot of other shit. Now, believe it or not, and this is the part that you don't have to accept it. You can come say, show it to me. I'm just not going to do it right now. Because it's not. All right. All the other shit becomes this. It's trying to be a meme. Got excited. So it's the sum of these minus the square of the mean. So in order to do this, and again, this is the variance. Even if you didn't understand any of that shit, I could have just thrown this at you and said, this is the formula. But I can kind of see where it comes from. It comes from the same formula we used before that we made, and we just reorganized it. And does anybody notice? So I need to, what do I need to get? I need to get a bunch of these so I can add them up, right? Do you see how I already have a bunch of x p of x's? How can I get a bunch of x squared p of x's? What do I get when I multiply x times x p of x? X squared p of x, right? So if I just do this times this, I'll get what I need there. And this seems like something you could do very well in the lists in the calculator, right? I would make L1x is L2 p of x is L3 would be L1 times L2. And L4 would be L1 times L3. L1 times L3. You guys kind of see that a little bit? Some of you guys? Some of you guys are like, what am I doing? So let's see, somebody help me out. What's 3 times 0.81? Actually, I tell you what, let's do this. Let's build this in the calculator. And then I'll give you that handout. And I'll shut up for a little bit. You promise? I promise. That's been on all night. Yeah. Oh, if you need to borrow one, you're going to need one today for sure. get into your lists.
Did he just do that?
Let's clear them all.
Like that's what it is. Okay.
Shit. Alright, is everybody with me? Everybody alright? Anybody's calculator freaking out? Anybody missing lists? Anything? Okay. So let's just put into L1, we'll put the X's. 3, 4, 5, 6. Put all your X's there and then burn it. No. And then L2. 27, 0.51. 0.1. So there's X, there's P of X. Then I want L3 to be X times P of X. So of course I want it to be L1 times L2. Is that cool? Because L1 is the X's, L2 is the P of X's. So if I go up to L3, highlight L3, make it L1 times L2, we should get the same numbers. Kabam. You guys see that? Same numbers we got up on the board. Kabam. Now there really are two ways to get L4, but the way I always do it is I do L1 times L3. If you understand that, maybe don't listen to what I'm about to say. You could also do L1 squared times L2, and it'll come out the same, because what's L1 squared times L2? X squared P of X. If you don't understand that, that's math. Math don't give a shit what order you multiply stuff in, right? And that's all it is. Yes? For L3?
Yeah.
So, I want L3 to be the X's times the P of X's. The X's are in L1, and the P of X's are in L2, so I'm going to make L3 go up to L3, and I'm going to make it L1 times L2. If you get a error, you probably are trying to put it in the list. Like one piece of it is a whole list, and the calculator's going to be like, I can't do that shit. You got to highlight the list to define the whole list. So what do I want L4 to be? Beautiful. If you're me, you want an L1 times L3. Shabam. So that's what would go here. Oh, that's a good check. If you're at home watching this, I'm sorry. So then you would get, and of course now I immediately go to the board.